Hello, everyone. I'm Justin, like Gray said, and I work mostly on the Lit core libraries. And the package I'm going to talk about today is the Lit Labs context package. So I'm going to go over some things, exactly what we mean by context, the package itself, and then some interesting things like the context protocol that this package is based on, and finally some use cases in a demo. So first, what do we mean by context? Context is a really general term. I think a lot of people in the front end web dev world will be familiar with its common usage these days, but not everyone. So let's give it a definition here. So I think the best definition I know of is that context is a way to provide data to an element tree without data binding. The data is contextual. It's just available without having to pass it around. So let's look at this in pictures. So here, imagine we have a component tree, and we have a value that is owned maybe at the root of this component tree that we want to make available down the tree. So we want any component further down in the tree to be able to get a reference to this value here. And so typically what you'll do with data binding is that in order to get this value from an ancestor to a descendant, you'll pass it down with data binding, which I've shown in these gray arrows here. And then finally, the component that needs a reference to it will have a strong reference to it there. And so let's look at what that looks like in code using just standard lit data binding. So first, we're going to name our elements here. We're going to talk about a root element, which has the value, a parent element, which is kind of in the middle of the tree, and then a child element, which needs the value. And so here we have our root element. We're going to implement this, and we're going to have this value foo here, which we want to pass around. So you can see that we have foo as a reactive property on the root. We're going to initialize that somehow. I won't show that here. And then we need to pass that down to the parent element. And this is the element in the middle of the tree. And then we have to implement the parent element. And in the parent element, we need a reactive property for foo so it can receive the binding. And then we need to pass it on to the child. And then finally, in the child, we need to have a reactive property on the child to receive that element. So you can see that every element in the middle of the tree, this parent element here, needs to have a value defined for this reactive property and to pass the value on. So we'd like to do something a little better than that, less boilerplate. So what context does is it says if you have a value available at the root of your tree, we're going to turn the element that owns that value into something we call a provider. And that provider is going to make it available to any element below it in the tree. And we're going to call those consumers. And they're just going to be able to kind of almost magically get access to that value. So now let's look at the package itself and how it helps us do this. So the context package gives you a few exports to let you provide and consume these context values. I'm going to show what I think are the three easiest ways to use it here. Create context, which lets you identify a context value, and then the context provider and context provided decorators. So if we want to use context, the first thing we need to do is create what we might call a context key. This is a way to identify the value that we want in case there are multiple values flowing through the context system. And then we can look at the root element here. And you can see that the difference is instead of defining a reactive property, we use the context provider decorator, and we use that context key here. And then we have our template, and we render our parent element, but we don't have to data bind into it. And next, you can see that the parent element doesn't have kind of anything to do with this context value. It doesn't know about it. It doesn't have a property for it. It doesn't have any data binding. And then finally, in the child element, we use this context provided decorator here, give it the same context key, and this will automatically get the value. Yeah, there. So this is what it looks like using context. We could kind of remove the parent element definition here because it doesn't really matter that much. And one additional thing you can do is you can subscribe to a context so that you can get all the changes so that everything is dynamic. And this way, if you set the roots value to the roots property to a new value, that'll automatically update. It'll update the context, and that will automatically update the child, and everything will stay in sync. So that's what using it looks like. You can install it here at the Lit Labs/context package. And then the main things it gives you here are the two decorators that I talked about, context provider and context provided. And then we have these reactive controllers, which are kind of like the implementation detail of the decorators, which you can use directly. And then we have a thing called context root, which is a way of buffering and replaying context requests for lazy loading purposes. Um, Okay, and so the context package is actually pretty straightforward and easy to use, like I showed there. Just add these decorators and basically just works. Some of the really interesting things about the context package, though, are how it works and the fact that it's based on a open community protocol that we call the context protocol. So this protocol is made under the Web Components community group. And this one was made by Ben Dallaire at Adobe, who contributed both the specification for the protocol and the context package itself. So thanks a lot, Ben. So you can go read it at the Web Components community group site. We'll drop a link somewhere in the metadata here. And the interesting thing about this protocol is how it enables interop and how it works. So I wanted to describe that a little bit. Um, so the main thing that context uses is an event pattern for being able to request items from above you in the tree. So the way that system works is we'll have a consumer and it wants to get a value. So it'll fire an event, and that might look something like this. It's just going to use a standard API to dispatch an event from the DOM. And then we have an event subclass here called context request event. That's going to take our context key and a callback so that the value can be provided to the consumer. Remember, this is low level. This is kind of how the context package works under the hood. So that event is going to go up our tree and it's going to get to the provider. And the provider is going to add a value into it. And the way that works is like this. So we're going to add an event listener to the provider for a context request event. It's going to stop propagation because it knows it can handle that context value and it doesn't need to delegate further up the tree. And then it's going to call the callback on the event with the value that it has. And that's basically the entirety of the protocol there. It's pretty simple. Um, Events are awesome for doing this kind of thing. If people don't know some of the details of how events work and why they're so suited for this, well, one, they bubble up the tree. And so we're trying to get values from above the tree, and that's great. They're also cancelable. You saw that stop propagation call. So an element can say, I have this value. My parents don't need to try to provide it. They're also synchronous, which is really important when you need a value and don't want to get it asynchronously. And they can have a custom API like that callback I showed on there. So that's the event-based protocol. It's interesting to think about how this is similar to and differs from framework features that are similar, especially Angular dependency injection and React context. So the first thing is that it's interoperable. Because it's based on an open protocol, this doesn't just work with Lit. You can use it with other libraries that might implement the context protocol. I think Fast has an implementation. Stencil might have an implementation. And also, you can see the protocol is very simple. So you could just do this in your own vanilla web components. It works with custom elements. This is kind of important and implied here, but custom elements don't have constructor arguments that you can rely on because the browser calls the constructor with no arguments. So we can't really do a traditional DI system like Angular has. So by working with events, we enable custom elements to have a dependency injection like system. And also, the DOM is dynamic. Elements can be added and removed over time. They can be reparented. And so by working with events, you can fire them at any kind of time in the DOM if elements move or the ancestry changes. And so this protocol works with a dynamic DOM like we have. All right, let's talk about some use cases here. You can do some very interesting things with context. So the first is basically what I showed you, kind of ambient data. So using context allows you to eliminate what is often called prop drilling, which is having to set these data bindings up all the way down through your tree. And so if you have some very commonly needed data like a user that's logged in, you can have a user context and then just get that in any component that needs it. Theming is an interesting case. Context behaves a little bit like CSS inheritance in that the values inherit down the tree. So for things that you can't do in CSS, like if your theming needed to include like extra templates or some JavaScript or something, you could have a theme provider provide these bits of behavior and style to components down the tree. Another interesting one is light DOM data flow. So Some people have made projects where they want their users to be able to kind of construct UIs and interesting object graphs just with HTML. For your light DOM children, we don't have data binding, right? Because they can come from any framework. So if the elements are interoperating over context, then the child elements can get data from their light DOM parent elements this way. So here you might have a page that provides a user and some kind of user display element that can display that regardless of what type of parent it's in. Similarly, a use case I really like is DOM-based plugins. Instead of just UI elements, you might be trying to make a declarative API or wrapper around a JavaScript library that is heavily plugin based. Well, it turns out if you provide the main API surface via context, you can make plugin elements. So you might have a text editor, and you're able to add language support by dropping in um, language elements inside of it. Okay, so now let's hop over to the one demo I have, which will hopefully show how this works. So over here, I have a little setup with two containers. I call them number container. We have the one with the blue value in it right here and the red value. These are both context providers, and they're going to provide the value that's in the input right there. So if we look at the container, we can see that we use the context provider decorator here. We've created a number context, which we've imported from a shared module. And then we have an input that's simply going to set the value field that is decorated here. And then we have this display element here, and this uses the context provided decorator here. It uses the same shared number context, and we're going to subscribe to the value so we can get updates. So now if we go over to the demo side, you see we can enter a value, and when we change it, that value is going to show up where we're consuming the context value. And we can have more than one subtree with different values here, even though they share the same context key. Over here, we're going to provide the value 8. So that shows how you can get a value to a subtree, two different subtrees here. And we can also show how it updates because we're subscribing to the value. So we can do 1 over here, and we see that updates. And then also, because we request refresh of context values when elements move, I added a little bit of drag and drop here, and we can see if we move the blue box over here into this context tree, we're going to get that new context value 8 right there. So pretty easy to set up, and you get some very nice dynamic behavior there out of it. All right, to recap, like Gray mentioned, we have a standardized set of statuses. We think context is pretty close to GA. We have a known set of things we want to work on before we graduate it. There's a couple of places we want to double check alignment with the protocol. We have some ideas for simplifying the names a little bit. We want to work on SSR support, improve some TypeScript typings. We also want to do some benchmarking to make sure that this pattern is fast enough to use for pervasive things like themes, and finally get some documentation up. Specifically, we're looking feedback on a couple of issues. One is upgrades. So if you have lazy element upgrades, how often do you need to upgrade a consumer before a provider, asking for a value before it's available? So we have a solution for that called context root. We want to get some feedback on if it's good. The decorator names, they're a little bit long and they only differ by one letter, so they're kind of hard to differentiate. So what do we think about renaming them to maybe like provide and consume? And then also, we don't have the ability to provide data to separate sub-templates inside of an element, just like kind of an entire host element at a time. And we need to see if people really need that or if what we have right now is sufficient. So please try it out. You can install it with at Lit Labs/context, and then you can open issues or join the discussion at our GitHub repo, lit/lit. And that's me. Thank you.
Awesome.